Okay, once again, good afternoon. Thank you for joining the webinar. Hopefully you can hear me okay and your system sound is coming through with my voice. If there are any questions, please do feel free to raise an issue using the GoToWebinar system, and any questions or comments throughout the webinar can be sent directly to infraworks360.emea@autodesk.com. That's a centralized email address where we can capture all of your comments and feedback and respond to you on a one-on-one basis accordingly. We will share that at the end of the webinar again, and you can also see it in the chat box on the right-hand side of your screen. So we are talking today about maximising design hours on civil engineering projects within the infrastructure segment with InfraWorks 360 and AutoCAD Civil 3D. So most of you that have joined this webinar are probably either existing AutoCAD Civil 3D users or existing AutoCAD users, or customers that have at least heard of and are aware of AutoCAD Civil 3D, being Autodesk's specialized vertical version of AutoCAD, specifically tailored for civil engineering project needs in terms of design, analysis and modeling. We're also going to touch on BIM and how BIM relates to the infrastructure segment as opposed to vertical building segment or the traditional architecture segment, which is more commonly or more previously associated with BIM, building information modeling. And we're going to talk about where InfraWorks 360 sits in Autodesk's portfolio and strategy, and why we prescribe the InfraWorks 360 in AutoCAD Civil 3D duo of BIM tools as a modeling workflow. So unfortunately I was supposed to be joined by my colleague Andrew Manzi, also of Autodesk, but there's been an emergency appointment which unfortunately he's not able to change. So we're going to cover BIM for infrastructure very briefly, just to make sure that everyone's okay with it in terms of the infrastructure world. And then Autodesk Civil Engineering Design Tools, process in terms of design process impacts. So BIM is obviously a process as opposed to a set of technology, and the technology are tools that enable that process. So what are the impacts and what are the takeaways, and how do you feel the result of implementing those processes on projects in civil engineering terms? And then looking at best practice for managing information and receiving more value from the same amount of information, and making that information more accessible but also securely managed. And then we'll put a couple of example scenarios. So we'll actually cover a small highway scheme, a junction realignment. We'll cover a hydrology scheme. So we'll look at analysing rainfall against topography, and then we're looking at designing a culvert to alleviate the effects of that rainfall and the runoff. And then we'll also look at a flat deck type bridge design, much like the many bridges you find, 90% of the bridges across the UK and beyond, and most motorway bridges. So first off, I'm going to play a very simple, very quick video. Now this gives an introduction to BIM in the infrastructure world. So obviously coming from natural progression, this is 2 minutes long, and we'll hopefully get everyone onto the same page. So to begin with, we obviously had paper and pen, then we introduced CAD, then we introduced three-dimensional modeling within computer-aided design, and then finally the next iteration for us is BIM, building information modeling. Now this is, as I said, a process where it connects all disciplines and connects a project team, and it's very much a project-centered process as opposed to a technology-centered process. So we have intelligent attributes and analytics attached and as part of the integral design. So geometry is not separate from analytics, and we have profile and plan connected together, and when one updates, the other updates as well, reducing the opportunity for data drop and data loss. And then obviously taking that and connecting the field and connecting to contractors. So utilizing that framework of managing information and managing context of the actual site, we're able to make more intelligent decisions, and we're able to carry that benefit through even into asset management. So an example here of designing in context with plan and profile all together, and designing in one tool but having another tool completely linked into that one tool and updating. So we have a central data repository building out this BIM model, and then we can look at the staging and constructability, and we can look at analytics in terms of flows and volumes and performance measures. And each stakeholder, from surveyor to project manager to client, is able to be connected and get the appropriate viewpoint to access their information. So a two-dimensional cross-section is entirely valuable, but not necessarily to every party. So we can use things like mobile technology, web and browser technology, and frankly technologies that we didn't have 30 years ago to be able to deliver, BIM methodology based projects. So Autodesk.com/BIM is a central BIM hub, or autodesk.co.uk/BIM for also some localized case studies and references. And then you can select infrastructure, utilities, or specific sub-segments from there on. So as I said, BIM is very much a process. So centering the process around people, collaboration and information. We can look at where the benefits are and what we're trying to achieve. So our high-level goals in terms of this civil engineering example with InfraWorks 360 and Civil 3D, and also a number of other tools which will come into play at various parts depending on the project. We want to enable people to perform more valuable and less manual or administrative tasks. So what that means is enable designers to design and engineers to engineer, not have the balance of their time and the balance of the cost of on the project and that valuable commodity being deployed to drafting and manual processes and items. We want them to be able to deploy their intelligence to make decisions to solve problems, as opposed to just simply drawing and manually redrawing. And once we get that process, once we have a model to work with, we want to ensure there's a logical step-based progression toward the end result, toward delivery or handover. And that progression should be smooth. And what I mean by smooth is that loss of progress or loss of data or errors or conflicts or issues are minimized. Therefore, we have less data drop and less drop in productivity as we move, for example, from one to the next, or from one project stage to the next, or simply as we hand over to a colleague performing the same task as us, but we get another hand in the pot. In terms of collaboration within our project team, we don't just always mean to stakeholders or the public or clients, but actually within the project team, either within our business or within subcontractors or lead contractors or peers, in the engineering team, but actually not within our own organization. So we want to allow visibility and accessibility. Remember, we're working off of intelligent attributes and intelligent objects within a BIM model. Therefore, we want our colleagues, which have separate, sometimes conflicting needs to us, to be able to balance their needs against ours, see why we are trying to achieve what we're trying to achieve, and us be respectful of their needs as well, so that we can reduce conflicts and we can click on objects, for example, and see the underlying data and understand why that geometry is such, and why that volume is such, and why the cost is such, and why the staging and the constructability is in that particular format. And that massively reduces risk for us and makes for a much more efficient project management process. So finally, in terms of managing information, we want to maintain control and have control and management of our information, but we also want to allow that accessibility, and finding that balance between accessibility and security is absolutely critical, especially for those of you which deliver projects in the public sector, publicly procured projects or centrally procured projects, for example. But ultimately, any client's data is of utmost importance to us, and so having a set of systems in place to deliver projects across the board is a lot more cost effective for us than having several processes depending on the client. So a question that we get asked at Autodesk very much is, what's your BIM tool for civil engineering? You have Revit. Revit is BIM. And Revit is not BIM. Revit, as I said, BIM is a process. Revit is a tool which enables BIM, a fantastic tool which enables BIM. But BIM is a process. It's not a technology, and it's certainly not one single technology. A BIM model is normally built up of a myriad of different technologies depending on the project, the contractual and the client needs, etc., and the site constraints and the environment within our spectrum, especially in civil engineering projects, which can easily be slightly larger than a building project and certainly on a linear scale. So we have Autodesk AutoCAD Civil 3D as a fantastic tool for delivering civil engineering projects, building off the AutoCAD platform and producing constructible detail through handover and documents and sheets and styles, etc., which can be read and understood by a contractor or a client so that the thing can be constructed and built into the real world. And then we have InfraWorks 360. Now, I use an analogy that we have with our building-focused, architectural-focused customers, where we have AutoCAD on the one side, which has finite detail and tried and trusted routines and a very mature technology which can go out and produce documentation, etc., and we can hand over and we can build our design. And yet, on the other hand, we have Revit, which works very differently in workflow to AutoCAD by design because it's a database-driven tool as opposed to a drafting and drawing-based tool. And it's graphical so that we can have more intuitive and quicker workflows so that we can understand what we're looking at and minimize data drop and minimize our inefficiencies. So for the civil engineering spectrum and civil engineering design, we can see that InfraWorks 360 is our BIM from infrastructure civil engineering design tool because it's database driven. At the heart of InfraWorks is a database, and it's graphical context in the context of the project as opposed to the technology, and in the context of the design and the site as opposed to a drawing template. And yet we can still utilize all of the very many benefits of Civil 3D and its maturity and its localization so that we can have this technology, these two products working together simultaneously, so we're using the right tool for the right job at the right part in time. And I could go on and on this slide and list Revit and Navisworks and probably some other tools from other CAD providers, from Bentley, for example, some other tools for analytical tools which we need to encompass in our wider BIM model. And you know, the screen would become very cluttered, but this essentially in simple terms is the central nucleus for civil engineering design projects of building out that BIM tool. And InfraWorks provides that project-centered connectivity and interface, and Civil 3D provides that back-end detail and documentation engine. So moving forward, we have the McLeamy curve, which I'm sure many of you will have seen before. It's a great visual graphic to depict several stages, and this is obviously reminiscent of various different types of infrastructure-related projects or AEC projects in the whole. So you'll see as we move from preliminary design, from, if you like, the kickoff on the left-hand edge is the project kickoff meeting, when we start to think, how are we going to tackle this project? We've won the project perhaps, or maybe it's even when we start to bid for the project and we decide if we have the capabilities to go after this work. Then we move through and we detail the design. Once we have a decision made on our proposal or series of proposals to take forward, we go out and we detail this design. Then we produce our documentation. Now that's not necessarily simple plot routine. We need to be detailing multiple different sections and views, and we need to be imparting our design to our contractor and to our client so that we get sign-off and so that it can be built appropriately. Because as you can see, as we move to construction, the cost of change once we have a physical clash as opposed to a digital clash in our model becomes greatly increased. And then we move through, and the reason asset maintenance or asset management or facilities management, depending on your own terminology, the reason that's included is because we want to maintain this BIM model, because BIM is a whole life cycle process, and we want to utilize that BIM model, or at least parts of it, but utilize the BIM model through to 24/7 life cycle management. And even if it's an asset that in 20, 30, 100 years time we wish to decommission, then we use that BIM model to decommission effectively and safely that asset, that design, that thing. and then we can use that BIM model again. Of BIM becomes a BIM model of the site, and it reciprocates. So in addition to the cost of change going up as you move to construction, you can see the ability to impact performance starts to decline as soon as a project kicks off, i.e. we need to have decisions made up front. Now traditionally, this is where AutoCAD Civil 3D sits for the majority of projects. This is the mean average workflow. Civil 3D is a very detailed design tool. It's a very large, very comprehensive tool, and it's not necessarily the easiest tool to pick up because of that valuable detail that it adds, that valuable analytic and documentation based output where we can actually go and construct something from our AutoCAD Civil 3D plans. And what we are trying to introduce with InfraWorks 360 and Civil 3D together is building upon and maintaining all of the value and placeholder of Civil 3D, but adding in some upfront decision-making intelligence, reducing our time taken to draft, reducing those manual administrative tasks, and making it possible for the designer to design, the engineer to engineer, and make those kind of decisions. And as you can see on the right, the majority of design issues are only encountered at a stage where it's expensive to fix them, i.e. in detailed design, documentation, hopefully not into construction. And quite frankly, it's only possible to collaborate and coordinate and bring multiple different designs together once you have those designs drafted up or modeled up or designed up into a model that you can then bring together. It's very difficult to start from the outset in a coordinated fashion utilizing Civil 3D. Now, Civil 3D is a fantastic tool, and we absolutely want you to continue using and helping us to develop Civil 3D to be the best that it can be. But we're simply utilizing other technologies to complement Civil 3D with InfraWorks 360. So again, it's a very generic and simplified graphic of what perhaps a BIM model may look like, and there'd normally be, depending on the project and the project team and the contract and the site, multiple lines which could be bi-directional or single input outputs, etc. And this would kind of be what it would look like. So we would have a central repository, maybe that would be DWG based, for example, and we'd have to federate in some DGN data. And we'd have our Revit buildings perhaps come in, and we'd have some scheduling through Navisworks, and we maybe connect to a database in here as well to look at our costings or maybe our resourcings. We would need perhaps an IFC output depending on deliverables and the client, and we'd need to incorporate GIS and planning data, and again, so forth. So quite honestly, what we often do is we often have a DWG format, but it must be a DWG format of a certain year, and then it would probably be a 3D AEC DWG, meaning that we can read AEC objects. Now the FBX, which comes and gives us three-dimensional geometry but not attribute data, and the RVT comes from our building BIM model, and the DGN gives us more vector data, and WGS is a database link, and then the shape files or the SDF files give us kind of linear planning attributes and horizon of GIS, and then IFC becomes an output, and very quickly we move and shift our focus as soon as the project kicks off toward technology. And that's because of constraints of technology, legacy constraints. And one of the things that we realize is that we're not focusing on the project anymore, we're focusing on the technology. So this extract is taken from a previous local authority tender portal. And I'm going to read this out to you. So they ask contractors and consultants to bid against these needs. Better facilities will be incorporated into the scheme, which will provide overall increased capacity at peak times to cater for retail, commercial and public developments within the city centre over the next few years. Now that is a very contextual statement, and the biggest takeaways for me is that it should be in context of the city centre, of the local environment. It's an overall project scheme. It has to cater for increased capacities over a certain peak period, and we're looking at retail needs as well as commercial needs, and there will be public developments coming on that we should be aware of. And this is very detracted and segregated from the DWG, DXF, FBX, RVT, SHP conversation on the left of the screen. So what we want to do is focus away from the technology and more on the holistic project itself. So how do we make this paradigm shift? By encompassing a BIM methodology, but at the same time delivering against the context of the site. So to answer that, let me ask you a question, a rhetorical question. How many project hours, which have an associated cost, do you spend searching for data and compiling models, drafting, CADing something up, before design work can even begin, before a decision can even be made? And do you deliver any of your projects, and do you kick off a project using tools like Microsoft Office and Google Earth Street View and things without engineering constraints before you're ready to start in Civil 3D and start spending money on and design time in detailed tools? Well, what would that look like if we were able to give you this context out of the box for each and every project? So this is delivered to you from a service within InfraWorks 360. There is no cost attached to this data. There is no cost attached to this model. This takes about 5 minutes for these models to be delivered to you, and you have unlimited models from around the world, pretty much anywhere from above minus 60 degrees latitude to minus plus 60 degrees latitude around the world. So UK and Ireland, for example, for this specific audience, and across the wider Europe, apart from some areas in northern Norway, are covered. So what about if we could give you this topography and these water areas and these buildings with building heights and names attached to them, with all the metadata in a database and railways and roads and aerial imagery, etc. And this is the starting point. Within 5 minutes you've not searched for data, you've not spent any time or any budget compiling a model. And this isn't a pretty picture, but this is very much a database to start designing against. And now if we're looking at this in plan view, would you have the same design context of understanding the severe topography in the distance? Or would you be looking at this in a series of vector lines from a plan view only, and knowing once you clicked on something only that it was a building, as opposed to a car park or a water area? So to put this in a suburban context, this is what it would look like, and this is actually a village within Berkshire in the south of the UK, to give you a local reference. And you can see the difference between the commercial real estate park and the train line and the routes, and you can see schools and you can see residential buildings, etc., with varying heights and attributes. And you can see where there is rural area, where there are multiple reservoirs, and these kind of geotechnical features which would absolutely need to be taken into account. And there are arterial routes such as motorways or bridges and roads. And this is something where I can, within 5 minutes with no manual work, I can click on this, and this road gives me the name of the road, the classification of the road, etc., etc. So how would this impact your performance? Now, some of the feedback that we get a lot is this project suitable for BIM? Or we don't do 3D on every job. And there are multiple other quotes that I could give you. But the fact is that, as I said previously, it's expensive to maintain different workflows, different processes for different jobs. Sometimes that's appropriate, but it's expensive to maintain those within a service-based company. So what about if we could utilize the data, the models, the base models, that context, that engineering database, to kick off every job and use BIM on every job and use 3D on every job? Maybe not to the same extent, but we don't need to worry about 2D or 3D anymore. We don't need to segregate between the two. We simply need to think holistically about the design. So let me show you one of those models in a different viewpoint, in a wireframe viewpoint, where you can see the triangulation of the topography, and you can see the water areas, and you can see the surface areas, and you can see the three-dimensional buildings with their roof slopes in triangles and points. Now it makes it clearer that this is an engineering database, not a visualization, and this is something we can design in and interact with. So this is how InfraWorks works. InfraWorks 360 at its heart utilizes an SQLite database, not a drawing or DWG, etc. An SQLite database, non-proprietary, as its model. That is what an InfraWorks model is. From there, you can set up a project collaboration group, and that could be that is entirely under your control. So it could be internal or external, and you can involve project managers or clients, etc. Or you could keep it within 1 or 2 designers or 3 or 4 designers within your specific office or team. You have that ability to set up that collaboration group. And then database connections. So and largely, lots of features which you may be doing in Map 3D or Civil 3D, as an example, in terms of database connections, can be done directly to the SQLite database, the InfraWorks model. And then this is not exhaustive, but if I run from left to right, BIM data from tools like SketchUp, Revit, or IFC imports, etc., can be brought directly and connected to the InfraWorks model. Vector-based CAD tools from Autodesk, not just two-dimensional drawings, but Civil 3D DWG, so it has intelligence to read an alignment as an alignment, and a pipe network as a pipe network, and a surface as a surface, etc., etc. And then IMX for a lightweight and portable infrastructure model exchange, Bentley DGN data from 3D seed files, DXFs from generic CAD tools. And then GIS data for planning, so shape files from Esri tools and SDF tools, produced in Map 3D and things like this. And then generic 3D models, survey data, point cloud, raster data, etc., etc., and it goes on. And all of those natively read by InfraWorks 360. It's an extremely open and collaborative tool. So I mentioned that InfraWorks 360 is based upon a project-centered focus as opposed to a just drafting-centered focus. So this is how it works. So we have the central project team. We have that set up. So the way this works is you pick your site and you download. This is where my project is. Give me that area, as you saw in the previous few slides. And that then is assigned to a project team, a job. And those within that project collaboration team, internal, external, that's your decision, have access to that model. And they begin to work and design. So a simple example for a highway scheme here. So we're analyzing things like curb returns, volumes, corridors, but we're also analyzing more subjective things such as visibility to the left and to the right at this give way line. And we can see the trees and the lampposts and the buildings giving us constraint on visibility and failure. So much more subjective things. So there are things that Civil 3D does to its strength, and they should be maintained as Civil 3D processes. And there are things that InfraWorks does that Civil 3D cannot do, or certainly cannot do to that level of detail. And so that's where InfraWorks should be used. And I'll explain how they're used as one tool shortly. So we also have another tool here, and this tool is tools within InfraWorks 360. So this would be a geotechnical model, or you can see the profile on the lower half of the screen here. And we're looking at grading, cut and fill, and quantities, etc. And what you can see the alignment in the canvas on the screen as well, and the triangulation of the surfaces and the corridors. And this is simply another function on the same model. And these two users are signed in. There's an audit trail of which one checked in their design change and on what data, what time, what was that change, and any conflicts between the two are resolved at project team level. So it's a much more efficient process. Again, it's a project-based workflow. Then we add in another user. In this case, we may be looking at Hydrology works, but because InfraWorks can handle slightly larger scale models, it's easier. So if you're on a simple culvert design underneath a simple road, the watershed running to that culvert could be quite large. So that's something we're able to handle in technology terms a lot easier within the software within InfraWorks 360. So again, disparate users within your organization, or again within your project team, your wider project team, checking in your changes, resolving conflicts before they arise. We can then take that model out to field. So we can do this for consultation, or for constructability with the contractor, for surveying, for project management. And it could be synced to an iPad or used on pretty much any mobile device whatsoever, Surface Pro, Android phone you see there. And so we're able to go out and we're able to make comments against the model. So we're able to push a geolocator comment in the model. We need to look at this potential issue. And that issue is then open until someone replies against it, closes it, is resolved, etc. And another powerful feature is being able to share the live model through a browser. So project management is increased. Project management meetings are made a lot more intuitive because you see direct visibility. And on the right-hand side of the screen there, you can see that there is a feed, a design feed we call it, where you can comment again and make those comments against the model. Now, in terms of managing this model or managing this technology, there's also an online portal whereby you can see which utilization you have, which users are doing what, and how they're utilizing the InfraWorks 360 team and model. And you can administrate your assets and your licenses and your project teams from a central web-based portal as well. So it's very easy technology to manage. So I used an analogy recently, which was the Revit-based analogy. So you use Revit, but you also use AutoCAD in that mix as well. And that's very similar to what we propose with InfraWorks 360 and AutoCAD Civil 3D. So this is graphical database-driven design. So when we look at this database, this is a very pretty picture, but let's not be seduced by the graphics. So this is a graphical engineering database. The brick wall is classified as a barrier in a hierarchy of the SQLite database. There is a geometry attached to the stop bar. Just past the pedestrians, you can see a manhole cover. Underneath the surface, you can see there will be a complete pipe network. There may be a creation date and a termination date attached to the vegetation, for example, for scheduling. You know, there are surface areas and volumes attached to the groundworks, and there are certain materials which are set up in there with costs associated with them, and the number of fencing panels and things like this. So to give you a different viewpoint, this is an extremely easy to use interface, but let's look at it as we go through the design. So in wireframe, you can see the pipe network underneath the local road. You can see the curbstones. You can see the alignments of the curb lines and the curb returns. You can see the heights of the fences and the difference. You can see the heights of the buildings and all of the different attributes. If we look at it from a different perspective, we can do environmental studying, and we can look very easily at what this will look like. We know where we are in the world. Everything is geolocated, so we know where the sun will rise, and we can do lighting studies, etc. And this is extremely important if you're in a very urban area, such as a city where you have taller buildings, for example, you're near tall structures. And then again, on the environmental context side, what does this development look like to the neighboring properties? Is this going to be visible from my bedroom window in terms of public consultation? And we can look at those again because we know where we are in the world, and we've given you a base model of neighboring properties, etc. Again, let's look at analyzing this. So we're analyzing the pipe network, and we see the pipes in profile view against existing ground with a 5:1 exaggeration, very similar to Civil 3D. We have the quantity on a pop-up card, and so we have the number of gullies and manholes and pipelines, etc., in their linear length. And we can see there's a barrel size of 500 millimeters. And then that's sized appropriately based on the rainfall which you would input in the topography and the surface geometry of the road. And we can see we can style those appropriately, and we can interrogate, and we can change. We're actually designing and engineering. And remember, an important takeaway in this slide is that all of this is performed before we've gone into Civil 3D. So this is all InfraWorks. Then we actually can look at full-blown traffic simulation and traffic modeling. So we can look at potential queue length, and we can look at time-based delay on the priority or stop-based control of free flow junctions, etc. So we can try and look at indicative performance very early on from a coordinated BIM environment, which is traditionally very difficult because of disparate technologies. And we can look at, specific OD matrix-based survey flows for traffic volumes. We can look at different behaviors of different cars, a different mix of different types of vehicles. It may be that our development is near to a distribution center with lots of heavy vehicles in one direction only. And we look at AM, PM, off-peak, on-peak, etc., as needed. And then again, we can look at running reports and highlighting features and interrogating this database. So for example, looking at cost and volume and schedules of what do I need to buy in material-wise for my panels and my brickwork. We can look at flood estimation and surface topography. So we can look at slope analysis and rainfalls and catchments and volumes, etc. And then again, we can look at safety, so we can look at visibility to the right in this case and plot site envelopes and failures. But again, all of this done within the single model. We can look at analysing the roadside grading, the cut and fill with slopes, with widths, with ratios, etc., and also with the profile view. And everything is entirely BIM process enabled in terms of updating the profile, automatically updating the vertical geometry of our 3D road model. So all of this data can be viewed again live within a browser. So we can give access and we can collaborate and we can confer and clarify with our contractor, for example, or our client if there's a progress meeting, etc. And again, we can even take this on field on a mobile device and control where we are. We can use things like augmented reality to turn the camera on the device so that we can see the model as built. Or perhaps we want to look at it and we want to place ourselves within the model in our specific GPS location. We can do all of these things, but most importantly, we can access this almost any time, almost anywhere. And remember, all of this is done prior to connecting Civil 3D. So again, we can adhere to local standards. We'll show you examples of where we're adhering to DMRB road alignment constraints and things like this, for example. But there may be more subjective terms, so things like manual for streets and local roads, where perhaps those kind of hard constraints that I mentioned previously aren't appropriate, but you need to be able to ensure that a refuse truck can move around the side of a parked car within the carriageway. You need to be able to see the context-sensitive shared space environment, or maybe you want to control whether or not that shared space environment comes into effect. So we need to look at the experience from a cyclist, from an NMU, such as a pedestrian as well, and impaired road users and things like this. And all of these kind of more subjective means. Now, the question I would ask you is it easier to design a contextual environment on a local scheme, on a collector road, a local road? Is it easier in an environment where you can see all of these different facets and you can experience the design and you can consult with the design and the client, or is it easier in a plan-based, vector-based, line-based CAD drawing? So what does this mean? Well, this means that when you kick off the project, you have better visibility. You're immediately coordinated and you can see the existing conditions delivered to you from InfraWorks 360 through the model building process. Again, free global data. And then there's less risk attached to that because you have that better visibility. You're less likely to go down a rabbit hole, as it were, and design against something and then someone come along and say, well, we can't do that, 20% through the design, you have to rework. Those kind of very common project scenarios are less likely to occur because of that increased visibility. So that less rework is one of the biggest takeaways for InfraWorks 360 with Civil 3D. And InfraWorks 360 provides the platform for collaboration. It's very much a project-centered tool. So when you come to deliver or hand over your part of the project, you're more likely to be on time, within budget, and it's again more consistent delivery as opposed to maintaining several different processes depending on the project. So this is what it looks like. We visit many customers. We're very fortunate to be in many of our customers' offices every week of the year. And we often see dual screens at the workstations of our engineer user customers. And this is what we are proposing for civil engineering design and BIM for infrastructure civil engineering design. InfraWorks 360 leading with the contextual graphical database-driven design for model attribute intelligence, and Civil 3D for detailing and documentation output. And what happens is Civil 3D is not an import or an export. It's not that you will take one file from your left screen and put it onto your right screen and then manually feedback design changes to your left screen. Remember, we're trying to enable designers to think about design and not administrative drawing tasks. So Civil 3D connects directly to the InfraWorks model, connects to the SQLite database. Now any changes I then make in InfraWorks can be seen in Civil 3D. You can then connect back, and any changes I make in Civil 3D can then be updated in the InfraWorks model, providing a true bi-directional data link, a very good data link. Now in InfraWorks we're able to see a contextual environment, and you can see we're working on this alignment and profile of this motorway going under this junction and this bridge here. But this on the right is vector-based line work in a Civil 3D corridor, and that is appropriate. So when you see an InfraWorks road, you'll see a Civil 3D, for example, alignment, profile, corridor, etc., etc. When you see a Civil 3D tin surface, you'll see an InfraWorks terrain. And there is a data translation between the two, updating the points geometries and the underlying metadata and attribute within the database. InfraWorks 360 model becomes the core for the BIM model, and Civil 3D connects directly to it with a bi-directional data link. So to explain that a little bit further, there is a bi-directional data connection, as I've said. InfraWorks 360 is then used for the 3D attribute-driven design, the project collaboration, and Civil 3D may be used for final tweaking of geometries, etc., detailing and documentation. Civil 3D is still a very important part of the process, but we're simply playing to the strengths of InfraWorks and playing to the strengths of Civil 3D. So to elaborate further, when you go from make an update in InfraWorks 360, what will you see in Civil 3D? InfraWorks will send and create in Civil 3D surfaces, road alignments, road profiles, curb returns, intersections, coverages, bridges, pipe networks. You won't need to create those. That administrative drafting manual process is removed. You can design against them, you can manipulate them, you can use your custom or bespoke drawing templates and bespoke branding, and all of your existing Civil 3D processes and experience, but the manual process of drafting the design on the bottom right is removed. And you achieve that design a lot quicker, often in somewhere in the ratio of 25% of the previous time it would have taken you within InfraWorks 360. What also comes across are planning, or what we call planning objects, or GIS-based objects. And what that means is you may not be that interested in where local roads are, for example. You don't want to slow down your DWG model with surrounding corridors of roads which you don't need to work against, but we're still going to give you a road alignment, a planning alignment of a road, so you know where the road is, so you have that context, you know where you're getting close to it and where constraints are in the surrounding environment, but it's in a vector-based CAD format. And then when you move back to InfraWorks 360, again, it's a bi-directional data link, and both are updated. So once we go back the other way, what kind of changes can we make? Well, as you can see, this time we're going back the other way. We've changed the alignment of this example road, and we can see that update within InfraWorks 360 within the core model. So horizontal and vertical profile road geometry updates within Civil 3D will be reflected back into InfraWorks 360. Corridor models can be sent across to InfraWorks 360. Pipe networks, for example, bridge designs, all again, those updates from Civil 3D, if you need to detail out or you need to tweak them, that can be sent across as a bi-directional data link. You have control essentially over whether and when you check in those updates and changes. So as we go through design, the models are updated throughout. Settings for how those models are updated can be saved and reused per project. And you can configure data translation rules. So, you know, when I create this object in InfraWorks, please create this object for me in Civil 3D. So this is a good takeaway. We can perform tasks in Civil 3D alone. It's a fantastic tool, and that's what many of our customers and many of you on the webinar are doing today very well. But ultimately, at times, it can become an iterative and detailed process with expert level skills needed, and that's why some of our customers maybe default to other tools that they know a little bit more, and there can often be secondary programs. Now, to make this more BIM enabled, by implementing InfraWorks 360 and Civil 3D together, it becomes a logical process which is progressive with many fewer steps. And as you can see, just a simple task here of a simple pipe for alleviating runoff underneath a road in terms of structure on this corridor, just under 8 minutes to just over 1 minute in InfraWorks 360 and Civil 3D together. So it becomes very simple, easy to implement process, a very short learning curve, and you end up with a central data repository. Now the takeaway is, when you have a detailed design with documentation with using Civil 3D alone, that's today, you could have a detailed design with documentation to the same level of detail, again, in this case, about 15% of the time, but you also have as a natural byproduct a three-dimensional model including surrounding site context and dynamic analysis and performance of the culvert in this particular example, of the junction, of the bridge structure, etc. So dynamic analysis within. So Civil 3D is still a very big important part of the picture, as I've said multiple times. You will maintain with this workflow many current Civil 3D processes. You will just complete them much more quickly. So for certain detailed design, it may be easier for you to use Civil 3D once InfraWorks has provided that design for you. Just for detailing, maybe. So if you need to deliver profiles, cross-sections, details, labeling, or plan production sheet sets, etc., and corporate branding based on your DWT template, then again you maintain those existing output workflows from Civil 3D, and because it connects directly to InfraWorks 360's model, there is less of a data loss. So you can adhere to graphical standards, as is true of many, many projects. So let's look at this now in terms of 3 examples of specific schemes. So number 1, a highway scheme. So we can look at this highway scheme, and again, please do not be seduced by the pretty graphics. This is not a visualization tool, this is an engineering tool for design of civil engineering projects. So we can see here we have a structure on the right, we have vegetation, we have a layout specific T-junction realignment, very small local highway scheme, we have a culvert underneath, and we have some cut and some fill on the 2 different roads here. So we can see as part of this we can analyze our site distances, and we can see obstructions potentially at the stop bar from things like trees and also the traffic signal pole. And then we can work on the profile and the alignment. Remember, this is prior to connecting Civil 3D to the InfraWorks model. This is all done within the InfraWorks design engines. And we can work on the roadside grading, the cut and fill of the corridor, etc. We can work on the potential optimization. So if we're a longer link road, we may want to optimize that road. Where would be the best place to put our alignment based on geotechnical demands, planning demands, topography, etc., based on cost and constructability? Or the profile, minimize our quantities for us in terms of volume profile optimization, and that will be a large detailed report and a new design placed in the model for you with quantities and volumes and cross sections and takeoffs, etc., produced automatically. So again, less administrative, more design. We can look at junction design, so we can look at turning zones, and InfraWorks 360 will create for you your curb returns, for example, to use automatically. You won't need to derive those. Those will be derived against turning scenarios and offsets and radiuses, etc. And we could have widening. And then again, traffic modeling. So we could be looking at different types of cars or passenger car units, and we could look at their behavior and their origin destination matrices and what kind of indicative queue length can we go from. We can do that at a very quick, accessible, early stage in the project. And then again, once we open that model, once we connect Civil 3D to InfraWorks 360, we get that 3-dimensional model. You can see with the curve returns and the profile and the alignment and the runoffs and everything else within. Automatically, these are untouched, so that's what you get within Civil 3D, straight from InfraWorks 360 in much less time. So let's take a hydrology project or a culvert example here. So as I said, we could look at a watershed, which is much larger than our small site, but the runoff to this area is particularly large based on this volume. So we can look at the statistics and the terrain behavior and geometries. We can look at the components, so we can model structural components, and we can look at upstream and downstream performance and throughputs, etc. And we can alter all of the diameters and barrel sizes and what the components look like. So make sure that we're picking something which we know we can get from a manufacturer and we know will deal with the job, and look at storage, etc. Then again, we can have hard reports on that, on the performance of these structures. And we can look at the quantities, the number of manholes, the number of pipelines, and what kind of diameters, etc. on these barrels. And again, once we connect Civil 3D to the InfraWorks 360 model, this is what you will expect to see. You'll expect to see data transferred into a Civil 3D pipe network, and alignment, and labeling, etc., etc., and then you continue your planned production workflow. If we take a bridge design project, again, please do not be seduced by the graphical picture. This is a fully integrated structural and civil model. So we can see here that we've analysed against sight distance in terms of the vertical definition of our road here, and forward vision, and looking at failures. And then we can look at individual components such as I-beams, steel I-beams in this case, and we can go through and we can see the quantities of the super and strub structures and see what is structural volume and what is reinforcing. And we can look at the different types of materials needed and do cost estimates and have a much smaller margin of error from day one on our cost predictions. We can go in and manipulate and change any one of these individual components, just one of the interior left beams, for example, or girders, as opposed to the whole bridge itself. And then again, we can even look at finite element analysis and structure models, so we can bring off the stresses and loading characteristics and tensions and bending moments, etc., to make sure that this is a constructible bridge. And again, for this example, once we connect Civil 3D to InfraWorks 360, this is the detail you will expect to see. And again, this is linked through to the core model, so it will be updated. So I'm going to show a short video here. Hopefully this will play for you at a decent rate. And this is just a simple workflow. So we create a model. We use the model builder service to create the model. In this case, this is Leeds in the UK. And so we go to the city centre and we pick a point. We just draw a polygon and say, there's my project, give me that site. Give it a name and assign it to a job. So assign it to that project team. And everyone within that project team then gets access. Now, once the model downloads, again, about 5, maybe even 10 minutes time, this is the kind of detail you can expect to see to design into, much more contextual than a line-based plan view. So if we take a very small example of a very small highway scheme, a small link road of a few hundred meters, you can see we're designing against DMRB constraints here in terms of our horizontal alignments, if appropriate. Junctions are created for us with curb returns. And what we can do is we can add pavement drainage in here, so we can look at the potential pipe network from a very early stage and then refine as we move forward. So if we go under the surface, you'll see the pipe network with the barrel sizes, number of components, etc., sized appropriately for the rainfall. Let's change our curb return radiuses in here and even add a flare lane perhaps for heavy left-bound movements. Again, extremely quick and easily. And then we can analyze the profile to optimize the cut and fill and reduce quantities, and make sure that that works in terms of performance of the road as well. And you can see everything we update is according to our BIM process. When we update horizontal, the vertical updates, it's one three-dimensional attribute. So then let's go through and we can even do things and look at the performance. So again, as we analyze hydraulic performance, we can also analyze traffic-based performance as well. So again, we'll get things like the queue length and the number of seconds delay that we expect to encounter on here as well. And we can run animations on here, but again, as I've said, just because it's a graphical interface, there is a lot more hard engineering data and decision-making data available within the database itself. So again, very quickly, and at this time I would ask you, how long would it normally take you to get to that level of design? And again, we can connect our Civil 3D directly to the InfraWorks model. So in terms of communication, a picture paints 1,000 words. But we can also work in a more traditional viewpoint if absolutely needed, and look at the holistics of this and look at the building with the terrain, with the surrounding buildings, with the line markings and everything else all in one model directly from our model builder service at the get-go. We can give the appropriate people in the appropriate part of the project team the numbers that they need to work with as opposed to the pictures. And we can give them paper-based reports and submittals as well. So give the right person the right information at the right time in the job. It's very project focused. So more than just designing faster, it's an intelligent engineering database with dynamic object attributes. The design is driven by analytics and those attributes attached to the objects. It's a project teamwork focused platform. It's very much a project centered tool, and it enables you to deliver additional deliverables to client in less time and effort it would take you with to just produce documentation on its own. So in summary, InfraWorks 360 and Civil 3D not only gives you faster design, but ultimately coordinated design, reduced rework, and greater cost accuracy. So I'm going to thank you very much for attending. I'm going to ask you to please forward all of your questions and comments to the email address you see on your screen currently, and one of our team, either myself or one of my colleagues, will get back to you directly. If you would like us to follow up with you more specifically and answer some further questions, we would hope that we have provoked some questions here today, and if you would like someone to follow up with you, please do make that request via this email address. In summary, coordinated design, reduced rework, greater cost accuracy. Use InfraWorks 360 and Civil 3D together to get there quicker and produce more deliverables to constructible detail. Thank you very much for your time, and I hope you found this valuable.